In this nugget, we take a look at DNS. We'll be taking a look at zones, first of all. That will be things such as primary zones, secondary zones. We'll also take a look at forwarders, such as conditional forwarders, but we'll also be taking a look at stub zones, which can serve a similar purpose. We'll take a look at the DNS cache as well as the client-side cache and how to clear both of those if they've grown stale. And we'll take a look at common resource records that you'll need to know about. Have you ever known someone to be called by a nickname? I remember back when I was in high school in my circle of friends, my very small circle of friends, I had a guy there that was a really smart fella, and he wore these tiny little glasses, so we always called him the professor. There was another guy that was a cross-country runner, and he was quite good, so we called him Jim Fix, who was a well-known running athlete back in the day. I don't really know that I had a nickname per se, but although I would like to put to rest this rumor, I was never called Tiny Dancer back in the junior high boys locker room, or in college or in high school or any of that stuff. Never happened. Make that very clear. Although I was called other names that were quite flattering. Yeah. Sometimes people would call me Genius, although it was with a strange tone of voice. It was like, "Hey, Genius," or Sherlock, although that was more like, "Hey, I'm glad you figured that one out, Sherlock." Not quite sure what to make of all of that. But anyway, we call things by names, including our computers, especially something like a website that you want to go to. You don't remember or even know in the first place the IP address of a website most of the time. You just type in www.cbtnuggets.com. That's because we like to call our computers by name instead of IP address. Sometimes we're mad at our computers and we curse at them too. But when you do that, you don't do it by IP address. I wouldn't look at the computer and say, "Shame on you, 192.168.1.7. You blue screened me again." Anyway, that's where DNS comes in handy for us because it's able to resolve a name that we can remember to an IP address that we're likely not to remember. So how does this all work out on a DNS server? Well, the DNS server just really stores DNS zones. Each zone is simply a storage unit, and it contains the domain names or host names and IP addresses of the hosts in a specific domain. Okay, we've kind of seen that a little bit before as we've looked at things such as SRV records, which we covered in a previous nugget, things like this. Now, for the most part, we work with forward lookup zones, but optionally, you can also create reverse lookup zones. Let's go ahead and take a look here just real quick at both of those. So just going over here to DC Nugget 1, which is my domain controller, we can see that we have a zone here for the domain nuggetlab.com, and it contains all of these dynamically updated host records. We'll talk more about dynamic updates and all later on. But anyway, what we want to do is, I can see that DNS01 is at 10.10.10.71, but especially in a larger organization, I just might not remember that particularly. So I could go to a command prompt. If I did remember it, I could type ping 10.10.10.71. Okay, fine. But normally I can't remember the IP addresses, so I'd instead have to ping by name, DNS01, and what it does is it contacts the DNS server, which is itself in this case, and it resolves DNS01 in that zone or in that domain to 10.10.10.71. Very simple. So let's get a little bit more depth on how this name resolution takes place, and as an example, I'm going to use opening up a web page. So maybe I'm sitting here at this computer. I don't know where I got that graphic. It looks like a Power PC from the 90s or something like that. Anyway, so I'm sitting at my Power PC, and I want to open up this web page, www.west.cbtnuggets.com, and I just type that into my browser. Now, from the user side of things, of course, they don't know anything about IP addresses. They just type that in, or they click a bookmark or something, and then automatically the content appears in their browser. But what really happens is the whole system has to get on their client. It has to actually resolve that to an IP address, because the browser, of course, actually connects to an IP address. It just puts the words up here in the browser for us to make it look like we actually know what we're doing. Anyway, so first thing it'll do is it'll look at its client cache, because it could be that earlier in the day I already used some method through all my DNS servers over here to resolve that. And if it's already been resolved in the past, then according to its time to live, which on the client side is usually an hour, then it will just say, oh, hey, I don't need to look it up and go to all these DNS servers again because I still remember it from the last time I looked it up. Also, you can preload that out of a hosts file. Now, that used to be how a lot of this stuff was done early in the days of name resolution on IP version 4 networks. A lot of the major universities and government organizations would just pass around and replicate manually to one another a gigantic hosts file until it got out of control, and that's when we needed DNS. what we can do is to preload that with things that we always know that we're going to have to be able to resolve, and we don't want to have to hit up the DNS server to resolve those for us. On boot up, anything that's in the host file, which is located in the Windows directory, System32, drivers, etc directory, that's going to preload in the client cache. Now, if it's not in the host or more directly in the client cache, then what it has to do is to contact its configured DNS server, and you've seen that before in the IP version 4 properties of your client, and it's of course also in the IP version 6 properties. So in those properties, we're configured to contact, 10.10.10.70, let's say, which is my nuggetlab.local maybe DNS server. Now the DNS server will do the same thing that I tried to do over here. It'll say, hey, do I already have this in my cache? Maybe some other person on the network resolved that like 60 seconds ago. And if they did, then I'll have it in my cache and I'll be able to load it from there. Or it may also have the same information loaded from its hosts file. Somehow I lost the word host over here. Anyway, it might have also preloaded that from its own host file. Okay, we don't really do that as much as we used to, but that could have happened. Anyway, let's say that it does not have that in the server cache. Now it needs to do the long process of resolving all of this. Now, from the client side over here, this is transparent and very, very fast, but in reality, there are several steps involved. First of all, it's looking for a domain that it's not authoritative for. So it's not looking for, www.nuggetlab.local, which it would probably have a record for or a CNAME for. So instead, it's going outside of its own family of names that it knows about, and has to go to this guy down here. I don't know anything about that. So what it'll do is it'll go to configured root servers, and there's a root hints record on the domain controller, actually on the DNS server, that will be able to point it to a variety of these root servers. And in reality, it starts at the dot. So even when you type in your browser www.cbtnuggets.com, in reality, the browser doesn't end at .com; it ends at .com dot. Okay, it's just that we don't have to type the dot in there. It does it for us automatically. So anyway, up here at the top, then it's going to be able to resolve. It'll have things for .edu, .gov, .tv, some of the newer domains, and so on. And of course, it'll also have a .com, and it'll then be able to refer to a .com server, where it will then be able to continue on the process. Now, it's at this point we need to pause and identify the difference between a recursive query and an iterative query. You see, when this client originally requested www.west.cbtnuggets.com, it contacted its DNS server with what we call a recursive query. That means that I just want to get an answer from you. Don't tell me to go ask somebody else over here. Just you find out for me and either tell me you could resolve it or you couldn't. Period. That's all I want to know. The only thing I'll get back is a single answer from nuggetlab.com with a yes or a no that they could or could not resolve that IP address. Okay. Now, what happens here though is that this nuggetlab.local DNS server, when it goes out here, it will then perform an iterative query. Iterative. Okay. And this means that it may have to query this server, and then this query will come back and say, well, I don't know, but I do know the .com server. So then it will go to the .com server. Then the .com server will say, I don't know, west.cbtnuggets.com, but I do know where cbtnuggets.com is. So then it'll point to that IP address, and I'll say, okay, well, then I'll go ask cbtnuggets.com. cbtnuggets.com says, well, I'm not authoritative for west.cbtnuggets.com. But I do know where that server is, so I'm going to point you back to that. And this is all iterative, where it goes back and forth and back and forth and back and forth through a bunch of referrals to eventually this server will then directly query the authoritative server of west.cbtnuggets.com, and West will say, oh, hey, I know, that's one of my servers. That's my www server. So I'm going to give you an IP address to that www server, which is where we then give the answer back to our DNS client, and from that point, the DNS server process is over with, and the system will enter the IP address based on what we've typed into our browser, and the resolution that DNS has done for us. Now, I also used a term there that you might have wondered about. It was authoritative. This means that whichever DNS server has the actual authoritative source information. In other words, I host west.cbtnuggets.com, so I know good and well who my hosts are, and one of them is www. Okay, this would be an authoritative I'll just put auth right there. Now, nuggetlab.local, when it sends the answer back to my client, does it host west.cbtnuggets.com? No. So it's non-authoritative. Okay? It's still a correct answer because I got it from an authoritative server, but it's a non-authoritative answer because it's just hearsay. It's just what this guy told me down here. That doesn't always have a direct relationship to anything we do on a daily basis, except that if we get a non-authoritative answer and yet the web browser does not open to this for some reason or it times out, of course it's for a number of reasons. It could be that this server's down, but if it's up and everything should be working properly and it still doesn't open up, it could be that we have a stale record. Maybe we resolved that 10 minutes ago for another one of our clients, and then unbeknownst to us, they changed the IP address down here on www, and they updated the DNS record over here on the DNS server. So now I have a non-authoritative answer that's also stale, and we'll have to work with the cache on that. We'll talk more about the cache here coming up. But if I had gotten an authoritative answer, maybe my DNS server was directly contacting this DNS server, then it would have been authoritative and immediately given me the correct answer. So just as a troubleshooting matter, sometimes you do need to know if you have an authoritative or a non-authoritative answer, and you might need to clear the cache. Now then, how do we actually go about creating another zone for a different domain? Maybe I've got another department that's going to be accusource.local. Well, I might need to create another forward lookup zone for them because maybe we need to start interoperating with them and sharing resources and being able to access their web servers and so on. So I simply right-click on that portion of the wizard at the forward lookup zones and create a new zone. It starts the wizard, which I then say I want it to be a primary zone, a secondary zone, or a stub zone. Now, a primary zone means that it's going to be a read-write copy of the zone, and it can be stored in a number of different locations. If I leave it in Active Directory, then it's going to replicate to all of my DNS Active Directory domain controllers. This option is only available if the zone where I'm creating this right now is also a domain controller, and you can see I'm doing this on DC Nugget 1, which is my domain controller. So that's makes this possible. The other thing I could do is make it a secondary zone. And if I do that, then it has to copy the data from a zone file on some other primary zone or some other secondary zone. Okay, so it has to copy it from somewhere, and then in that case, it's also going to be read-only data. Then there's also a stub zone, which we'll come back to later on, and that just quickly and easily allows me to access key information about whatever DNS server holds that zone. We'll come back to that a little bit later on. But for the time being, I'm going to also store this zone in Active Directory. I strongly recommend that you do that whenever you can, because then you'll have something else called multi-master replication, meaning that you can update the zone data on any of the Active Directory domain controllers that have this zone, rather than being limited to only a single DNS server. It also gives you better redundancy. So we'll click on Next. Here I need to determine how I want the zone data replicated. It could go to all DNS servers running on domain controllers in this forest of nuggetlab.com. Now, you have to be a little bit careful about this. In a small environment, it really doesn't even matter. There's hardly that much traffic that's replicated or anything. In a large organization where you have many, many levels of child domains, maybe a lot of different namespaces going on, this could start to amount to a lot of replication data. So you just have to be a little bit judicious in how you do this, and it just depends on what you can afford in terms of all that network traffic. Here I'm just going to leave it in the domain, but again, we could go into the forest. Since I only have a single domain in my forest, it really doesn't matter which one of these I choose. I can also say to all domain controllers in this domain. Notice the verbiage difference. All domain controllers, all DNS servers, okay, on domain controllers. In 2000, it was not able to distinguish DNS data from other Active Directory data, and so we would just have to replicate everything. So here we can be more discriminating and only replicate just the DNS data on domain controllers in specific domains if we want to. Okay. Then I go ahead and enter in the zone name. I'm just going to say accusource.local, and we'll go ahead and click on Next. Then we can say what kind of updates do we want. Generally speaking, it's strongly recommended. They only allow secure dynamic updates, and that prevents a hacker from plugging into your network somehow and populating your zone with false records or poisoned records of some type, or redirecting your www.accusource.local to their own copy of www.accusource.local, whereas that has all kinds of viruses and spyware or something else like that going on. So the secure dynamic updates ensures that only members of the actual domain who've been authenticated are actually able to update their records in Active Directory, And that's how we got these updated back here. I never put those in there manually. They put themselves there because they authenticated against Active Directory and they were able to update their own record. I could also say allow both non-secure and secure. You would really only do that if you had some hosts that did not understand Active Directory, that were not able to be members of Active Directory, but you still wanted them to be dynamically updated. It's pretty much a vulnerability, though, not recommended, hence the big yellow exclamation point here and all of that. You can also choose not to allow dynamic updates, and that's okay for some types of zones where you want to tightly control the host records. Maybe there's only going to be a few host records in there anyway, and it's not really unmanageable in that respect. But in a large Active Directory environment where you have hundreds or thousands of host records that could be updated regularly, you probably want to go with this top one up here. That's pretty much it. Then we just click on Finish, and now we'll see that we have here accusource.local, and it automatically pre-populates with a couple of entries there. The zones actually have to have two things in order to be able to work. One of those is a name server record. If we double click on that, we can see it takes us directly to the name servers tab here, and then we have however many we've got. I've only got the one right now, but if I had some others like a secondary or something like that, they would also appear in this list. To do that, I could just click on Add down here and type in the fully qualified domain name or type in an IP address and then just add that in. One of the key reasons why that could be important is because we want to make sure that we transfer the zone and allow copies of the zone only to be made to other DNS servers that we trust. Again, we wouldn't want a hacker to plug into our network, pretend to be a trusted DNS server, and then collect all of our zone registrations. Then it would be able to figure out where my Exchange servers are, where all the domain controllers are, all of my host names. All of that stuff could be compromised then. And you'll see that over on the Zone Transfers tab here, where we could choose to allow zone transfers. This is insecure to allow it to any server. But we can also choose only to servers listed on the Name Servers tab, and then that way we would more tightly control where the zone transfers go. Although I could also be even more discriminating if I wanted to and say only the following servers. So even though I might have other name servers listed on the Name Servers tab, I could specify only a subset of them here on this list if I wanted to. Now, while we're at it, let's go ahead and address some of these other tabs. The first thing I want to point out is that even though it looks like we have two things going on here, they really point to the same element in the DNS interface here. Because if I cancel this and then now double click on the SOA record, guess what I get? I get the same dialog box. It's just that it doesn't take me directly to the Name Servers tab. Okay, that's where we started. So this is really the same thing. But anyway, the Start of Authority or SOA record, first thing we have here is a serial number. This helps to keep track of how many changes have been made to this zone. And it helps to synchronize everything if we have updates on more than one server. And if we want to, we can also increment it. So if I want this to be more authoritative, maybe there's another DNS server that also hosts accusource.local, and it's a legit server, but I want to make sure that my records here are more authoritative somehow. I can increment this by clicking the button. Now you see the numbers change to 2. Here's the primary server of dcnugget1.nuggetlab.com. I don't know if you can see this, but at the end here, let me get my zoom tool out so you can see this a little bit better. It's not working. Let me try it again. If I click my little zoom tool, there we go. There's actually a dot at the end of nuggetlab.com. Remember I said that earlier, that it actually goes up to the root at the dot at the end? Well, there it's a little bit more literal, and you can see that there. And there's this responsible person, and that's the hostmaster.nuggetlab.com. This is actually an email address that would be advertised to anybody that's trying to contact whoever owns this domain. Now you might say, James, that's not right because you forgot to put the @ symbol in there. Well, first of all, smarty pants, I didn't actually enter any of this in. It enters it itself in automatically. And secondly, there's nothing in the interface that allows for an @ symbol. So even though it says hostmaster.nuggetlab, it actually symbolizes this as an @ symbol. So if we needed to email somebody, we would enter in hostmaster@nuggetlab.com. Let's take a look at these items. Refresh interval. This currently has no significance because I don't have any other servers that are hosting accusource.local, for example, any other secondaries. If I did have a secondary, then it would refresh with the accusource.local here primary every 15 minutes to see if there's any updates, any new host records or anything like that. The retry interval means that if it's unable to contact the refresh interval in 15 minutes and it's not able to see the other DNS server, then it'll wait 10 minutes and try again. And then if it's not able to do it at all after a day, then it will just give you a red X on this zone, and the zone will be unavailable for service. There's also a minimum default TTL, that's the time to live. This means that anybody that resolves out of AccuSource.local will have a time to live for any of the host records that are created in here. They're going to have a default TTL based upon what we see here. So in other words, if I created a new host record, it would have a TTL, or a time to live, of 1 hour. That means that it would exist in the cache for 1 hour on my clients. And then the TTL for this record, in other words, this entire SOA record, is good for a day. Okay, so that's what that relates to. So if I needed a secondary DNS server, first of all, why would I need one? One reason would be because I might want to distribute the load. Might want to have part of my network clients pointing to DC Nugget 01 for AccuSource.local, and I would just enter that in their DNS server properties. On the other hand, I might want another part of my network accessing a different DNS server so that I'm not always hitting up DC Nugget 01, because I might want to load balance it a little bit. Also, it might be a good idea just so that I have some redundancy there. So I might go to DNS 01 over here, and then I would go up here to install DNS first of all. So I click on Manage. I'm clicking and nothing's happening. There it goes, finally. It's Saturday morning when I'm recording this, and apparently this server wanted to sleep in a little bit instead of actually going to work. So now I click on Add Roles and Features. Nothing's happening again. Boy, this server's really feeling sleepy today. Anyway, we'll click on Next, and this is all pretty quick. I'm just going to quickly blitz through this because you've seen me do this before. Same thing that we've done for other kinds of roles and features that we've added in. It's just that this time we're adding in DNS server. It automatically adds in the tools that we'll need to manage it. Then we'll click on Next. Then we click on Next because we don't need any of those items, and we'll click on Next and then Install, and then that'll pretty much be it. It should not need a reboot, so I didn't check the box up at the top, but other than that, it should just take a couple of minutes to install, and we'll be ready to go. Alright, looks like it's finished, so I'll go ahead and close this up, and then we'll be able to have on the Tools menu the DNS server. So we'll crack that open, and then we'll be able to maybe do a secondary. Let's just go ahead and do that. Very simple. Similar to what we showed you earlier, I'm going to go to a forward lookup zone and create a new zone. This time I'm going to go to a secondary zone, and I have to point it to the AccuSource.local primary, which is DC Nugget 01. So it's going to be AccuSource.local, and I click on Next. Here I'll enter in 10.10.10.70. And it resolves that to DC Nugget 01. That's okay. Okay, we're good there. We'll click on Next. And then we'll click on Finish. Now we'll see here that it's going to be the secondary for AccuSource.local. But we get a red X. Now this is something that's just kind of characteristic of DNS. It hasn't had a chance yet to replicate any records from AccuSource.local. So if you just give it a little bit of time, sometimes you have to refresh it every now and then, especially if it's an Active Directory integrated zone. But in this case, do you remember what AccuSource.local was? It wasn't quite the same as that. Let's go up here again to our DC Nugget 01, where we're authoritative on that particular zone. And as we go over to name servers, first of all, we see we only have the one. Well, I need to add in another name server here, don't I? So I'm going to enter in dns01.nuggetlab.com, and I'll resolve that, and it resolves it for me. Okay. Oh, let's go back here for a second. You might have seen a little message out here. Red X. That's always alarming when you see that. That's really not a problem here, though, because all that's telling me is if you look at the message that this server, let me get to it. If I hover over it, let me try it again. There it goes. It says, with this IP address is not authoritative for the required zone. So in other words, 71 is not authoritative. I already know that because DC Nugget 01 is authoritative. So no cause for alarm there. We just click OK. And then we go to zone transfers to allow zone transfers. And then we'll say to only servers listed on the name servers tab as a more secure option. Once that's been done, I go back over here and I'm going to try to transfer the zone over. So I'll go over here, right click on it and choose transfer from the master. Okay, and then sometimes again you have to refresh this and everything. There it goes. And so now it seems to have picked it up and everything is working out okay. Now it shows both the original name server, which is our primary, and then this one as a secondary. Oh, you may have seen something else there too. Let me go back to this. You see this transfer new copy of zone from master? Let's talk a little bit about the differences here. If it's Active Directory integrated, it's able to replicate only the changes. In other words, I might have 3,000 host records in this zone, And I've added 1 just today. Well, the next time it replicates that with its other DNS servers, it's only going to replicate that new one plus some checkpoint data. The other thing it's going to do here, though, is if I suspect that there's corruption in my local copy of Active Directory and so on, I'm going to just say, forget it. Just give me everything, and I want to kind of start from scratch, so to speak. This could also be the case if I'm using zone files that are not Active Directory integrated. I can transfer from the master, but I can also choose a whole new zone file from the master. And in this case, we have a little bit of both, don't we? Because remember, accusource.local on DC Nugget 1 is an Active Directory. Here, I specified it as a secondary, and when it's a secondary in this case, it's going to use a zone file. Let's go ahead and take a look at it. Here, if I just go into computer, the local hard drive, I'm going to go quickly through this, so keep up with me here. Windows, and then System32. Then there's going to be a DNS folder down here, okay, right there. And then here we have the zone file, accusource.local.dns. And for curiosity's sake, let's just go ahead and crack this open in Notepad. So I'll just open this with Notepad. And you can see here, all of the same information that we saw in the graphical UI dialog box is also here. It just gives us the same data. If I had any zone records, which I don't have any yet, they would also appear in this list. Now then, here I've gone back to DC Nugget 01 in its DNS console, and you can see, just for simplicity's sake, I've added in DNS 01 down here just so that I don't have to flip back and forth between machines. And I've also had DNS 02, although I'm not actually sure we're going to use it today. But anyway, you can see here, let's take a look at another item relating to the types of zones we can work with. We've only been working with forward lookup zones, where I ping, say, win8 client 01, and it gives me a response back from 10.10.10.100. Okay. Actually, that one finally woke up as well. That DNS server really wants to sleep in today. Anyway, but we've been able to do that and to ping these clients by name to get resolved IP addresses and get responses back. Sometimes you want to do the reverse of that, though, don't you? So, for example, let's say I'm getting really weird traffic on my network from, let's just say it's 10.10.10.100. We don't know why. Maybe it's a hacker that's gotten into our network. Maybe they're trying to do brute force attacks against my passwords, which generates a lot of traffic if they're careless. Or maybe I've got an interface that's failing on a particular host. When that happens, they also generate weird traffic. So I only know the IP address. I don't know the name of the host that I'm looking for. But if I go to reverse lookup zones, I don't have any. What you'll often want to do, especially in zones that you might want to troubleshoot a little bit more frequently, or that you want to make available for other people to be able to do reverse lookups for, is to be able to right-click here to choose New Zone, and then allow them to ping an IP address and get the result back as a name. So I right-click here to choose a new zone, and I'll click on Next. And again, you get the same stuff. It's just the same stuff we saw before. And then, again, I can choose the same options that we saw before here as well. And this is going to be an IP version 4 or IP version 6. Okay? You just enter in whichever is relevant, respectively. And then you enter in the network ID. It used to be that you would have to enter this in backwards. In a reverse lookup zone, it actually looks things up literally backwards. So if my IP address range was 192.168, let's just type it in, 192.168.1, for example. Notice that in reality, what it does is it looks it up backwards in this format, in this ARPA notation here. But I'm in a 10. Network, so that's going to be quite easy. Forwards and backwards, it's the same for 10.10.10. Okay? Anyway, I'm going to go ahead and click on Next. And then, again, I'm going to choose whichever ones of these is relevant. I'm going to choose only secure dynamic updates and finish. And then once that's been done, I need to make sure that I actually get registrations in here. Right now, I've only got the same stuff I always do with a new zone. I don't have any of these things, though. Any of my hosts, none of them are in there. Okay, so how do we resolve that? A couple of things you can do. And number one is I double-click on this. I can also update an associated PTR or pointer record. Okay, and then the next time this host updates, it should give me an update down here. Now, why didn't I get anything? Well, because I haven't updated yet. This will happen periodically on its own, but if not, and if I want to manually do it, I'll do an ipconfig / blanked for a minute, register DNS. And that will re-register my records in DNS, and of course I'm not entered in as an administrator, so James has to do it over again. So he right-clicks here to choose Run as Administrator, clicks on Yes, and then this is why people call me Genius and Sherlock. Okay, so I'll do an ipconfig and then a register DNS. Okay, there we go. Now, once that's been done, when I go back down to my reverse lookup zones and I refresh the screen, we can now see that it has reversed itself, so to speak, and put a reverse lookup zone entry in here. And again, those are called pointer records. Now, let's go ahead and kind of review some things. I've already addressed most of this, but let's just catch up a little bit. When we work with our DNS zones, they're stored in a file, which I showed you there is one kind of thing you can do, or they're stored in Active Directory, which is usually the preferred method if you can. In a file, they're stored like this, and I showed you an example of our accusource.local on our secondary. Remember, you can have a primary and one or more secondaries, especially if you're working only with zone files. If you're strictly working with zone files, you only have one primary ever. There's only that one. And then you may have multiple secondaries. Okay, the primary is read-write, remember that. Okay, the secondary is updated either by their primary or by other secondaries. So you might have, this server here is a primary. This one's a secondary. I'm going to have another secondary. This one gets its updates from the primary. This one gets its updates from the secondary. Okay, so that could happen. You try to not go too far out because then you start to get latency in terms of updates and things like that. But certainly, if you have practical reasons to do that somewhat, it's available. Also, I could use an Active Directory integrated zone, which is what we want to do in most cases. This is going to be stored in Active Directory, and it's going to be able to replicate with other Active Directory data incrementally. So again, if I've got 5,000 host records in a zone, but I've only added one new one, when it does its next update, it's only going to update that new one plus a little bit of additional overhead data. Then we have our secure dynamic updates. This is going to be something you certainly want to do so that only authenticated hosts are able to make entries into our zone, and that way we can avoid false records and poisoning and things like this. Now let's take a look here also at something that's very important for DNS, especially when it comes to resolving names that your DNS server is not authoritative for. That is forwarders and stub zones. With forwarders, what happens here is you have something called root hints, at least by default. And with the root hints, that's where we get our internet top-level servers, and we saw that in our diagram here earlier. So our root hints would be, and in the diagram there's only one server there, but there's really a bunch of servers up here at the top level that can then further resolve further down into .com and .gov and .edu and so forth. And if we were to take a look at the properties of our server, for example, we would see that there's a root hints tab over here. Now this root hints points to those root servers. This is where it's going to point to .com, .gov, .edu, and all those other ones up here. Notice that there's now also IP version 6 DNS servers that are seated out there. We didn't used to have those previously. Now, it may be that instead of going directly to these root hints, I may have forwarders instead, and very often what an organization will do is point to either another DNS server that it has, that it knows already does a lot of these queries and probably has a lot of the queries already cached inside of its own memory already. Or, very often, we'll also point it to our ISP's DNS servers, because not only are my users querying against that DNS server, but all kinds of other users are for that same ISP as well. So very likely that it's already cached in a recent past the same query that I'm actually looking for. So I might just put in an IP address for one of my DNS servers. Now, in this case, it's not resolving a name because it doesn't have a fully qualified domain name. This is just pointing to my own home internet router, which in turn would then point to my ISP. So to kind of clarify that out here, when we have our clients querying against my own internal DNS server, my internal DNS server doesn't have a lot of direct activity out here on the internet. Maybe we don't even want it to. So we would just point the internal DNS server to an ISP's DNS server, which is constantly resolving all this stuff out here. It's already in its local cache, and so then it's very easy for it to just send it back here, and we have a very short round trip to resolve that query. Another thing we might do, and let me kind of clear up a little bit here, is we might make this a caching-only server. Let me type that in here. Here I am writing. Did you ever see a typewriter that was this messy? Caching server. Okay. I say typewriter as if you were all as old as I am. Anyway, here we have a caching server, and what it does is it doesn't have any zones of its own. So, for example, if I were to go back here to this server here, let me clear that out. If this was a caching-only server, under forward lookup zones, there would be nothing here, because it's not authoritative for any zones, and it's not supposed to be. All we want it to do is we want it to point to root hints or to our ISP. We could even chain it here, our ISP's DNS server. And our ISP, again, resolves that on the internet if we wanted to go that far. Okay, but it doesn't really matter. The only point here really is that it's just caching. And the advantage of that is it's going to be very, very fast in resolving things for us. And as a better advantage, it doesn't have any zones that anybody could hack against. It's not authoritative for anything, so no one will be able to force it to do zone transfers because there's no zones to transfer. And the only thing this server really knows is what it's been told. Let's take a look at another kind of a forwarder, and that's a conditional forwarder. We use this if we have another domain that we commonly access. Maybe it's a partner company that we're doing business with, but we don't really manage their domains or their zones or anything like that. And we resolve things in their domain a lot, but we don't want to have to go all the way through the internet or through some other roundabout method. So instead, we want to go directly to their DNS servers for these commonly accessed domains, one or more domains. So, and as an example for that, let's say that I'm working with hisearthmyworld.com, and we access their resources a lot. We want to be able to resolve their name quickly and efficiently. So what we could do here is to work with a conditional forwarder. This means that any clients that have DC Nugget 01 as their DNS server will now be able to use the conditional forwarder to go directly to this DNS server to resolve it instead of having to go through any other roundabout methods. And by right-clicking here, I'm going to configure this for hisearthmyworld.com. And so then I'll just enter in the IP address of the server that's going to resolve this. You could do fully qualified domain name too if you can resolve it. And there it is, and then I'll just press tab and click OK. And there it is now, hisearthmyworld.com. And it's going to mean that, again, anybody who uses this DNS server as their configured DNS server, when they try to go to hisearthmyworld.com, it's going to use that DNS server to resolve it. Also, down here in hisearthmyworld.com, I've got a www record, which is just a host record in this case, but sometimes we'll use C names. In this case, I put www, and that means that it's going to go to this IP address. Let's try that out on a client now. So I'm going to go to Windows 8 client over here, and I'm going to type in www.hisearthmyworld.com. I got to come up with an easier domain. And then we see that it does resolve this. Now, you might also look at this and say, hey, James, how do we know your ISP didn't resolve that directly instead? Well, let me show you what I can do here to prove that. Let's just go to NS lookup. And you don't need to know this for the exam. It's just a handy tool to use. And then I'm going to set type equals NS. So in other words, I'm looking for name servers. And NS lookup is a tool that we use to work with a lot of DNS troubleshooting issues and to find out information about what's going on in DNS. And then I'll just say www.hisearthmyworld.com. And let's see what it's given me here. Okay, the server that it used to resolve it was DC Nugget 01. But in reality, the primary name service for that is dns02.nuggetlab.com. Okay. Now, in reality, again, there's actually on the internet a DNS server that does resolve this for me. I kind of short-circuited it, though, by using my own server instead. But that's part of the beauty and the flexibility of DNS. Now, the next thing we can do is to use stub zones, which have some similarities to conditional forwarders. Conditional forwarders, you enter them once, you specify exactly the name of which DNS server you want to handle the name resolution. You saw me do that when I pointed it to 10.10.10.72. Stub zones have a little bit of an additional advantage, however, because they will contain authoritative DNS server resource records, including these portions right here. That's what it actually uses. And these will be automatically updated if there's a change. Whereas with conditional forwarders, you have to manually update it if the DNS server IP address changes or something like this. So what the stub zone will contain is the start of authority. We took a look at that. Remember, you double click on it, brings up that tabbed interface for that particular zone. It brings up the name server record. Remember, those are the two things, the SOA and the NS, are the two things that are already there in any zone that you create by default. And then it will also create an A record, also known as a glue record. And when we're talking about stub zones only, though, normally you don't call an A record a glue record, but it is when you're referring to stub zones. And that's because it will point to the exact servers that are performing the resolution. And as I said before, these will also make updates. So, if I have some A servers, A records for my DNS servers and the IP addresses have changed, or I've added or subtracted A records for more DNS servers, then those will also be updated in the list. So let's take a look at how this would work. Instead of creating a conditional forward to hisearthmyworld.com, maybe I would want to work with a stub zone instead, because the stub zone would automatically update if there were additional servers that came out available to resolve that. So I'm going to right-click here in DC Nugget 1 for a new zone, and I'm going to kind of go quickly through this because you've seen most of this before, but I'm just going to store it in Active Directory for hisearthmyworld.com. By the way, I used to be able to do this for like Google.com and Yahoo.com, and I was actually able to transfer certain zone server information. And I think they must have caught on to me because they blocked that now. Anyway, so what's the IP address? 10.10.10.72 is the one it is. Okay, and we'll click on Next and Finish. And now we've got a stub zone here for hisearthmyworld.com. And if I give it a moment here, it can transfer from the master by right-clicking here. Then it should be able to eventually get the records from hisearthmyworld.com. Maybe I need to refresh this too. There it is. Okay, so it looks like it now got the NS record, the SOA record, and if there was a glue record in here, which there's not a glue record for this server, then it would have pulled that over as well. Now, we've talked about cache management a little bit previously just by showing you the cache. Let's address some additional details here. Remember, the DNS server cache is going to prevent those redundant lookups, so we don't have to go all the way back out to root servers or your ISP or something like that. They're usually valid for a single day according to the start of authority. Of course, you can change that if you want to, but 1 day is usually good. And then we need to talk about how to clear that if necessary. That's usually going to be important if the IP address or some other configuration has changed for the addresses that are resolved in the cache, and you need to update it. If you clear the cache, it'll do a full resolution again by going out to root servers or wherever it needs to go. So you can see here that on my network at DC Nugget 1, somebody's been browsing the internet. What have they been doing? Obviously, they've been going to Facebook. We can't live without Facebook. They've been going to Google, Microsoft. What else have they been going to? Okay, some of these are probably ad sites and stuff like that. That are little banners and things that pop up on some of these other sites. Anyway, so we've got some stuff that's been cached in here. Well, it might turn out that some of that stuff has gone stale now. Maybe Google changed their entire IP addressing scheme overnight, and now all of my records are stale in here. Nobody can seem to perform searches. Or heaven forbid, nobody can get on Facebook. Boy, the help desk phone is going to ring off the hook if that ever happens. So what can we do here? Well, we can clear the cache by going up here and choosing Clear Cache, and that's really all you do. Another thing you can do is, and this is how I've done it very often. Oops, I'm in another tool here. Let me clear the screen. I was just fiddling around with Yahoo.com. Don't pretend you didn't see that, folks. Let's clear the screen. Anyway, so I can clear the cache. I can do DNS CMD /clear cache. Okay, and that will also clear the cache. If I go back over here and I refresh the screen, we'll see that we now pretty much have really just about nothing resolved now because I cleared the cache. All right, let's also talk about the client-side cache. Now, the client only receives results from whatever the DNS server has resolved for it, and then it stores that in its DNS client cache. So let's go to my Windows 8 client over here to see what's been going on. Apparently, I've been surfing for videos on YouTube. Actually, it's probably my son that does this. He's a YouTube fanatic. Anyhow, so kind of tempted to park on this screen for just a minute. But anyway, let's say that YouTube has changed their IP addressing scheme just in the last few moments. And so now when I try to access any videos or something like that, nothing works anymore. Now, more realistically, I'm going to go to an administrative command prompt here. More realistically, what's going to happen is that we probably will have something like a corporate IP printer, which is identified by name and DNS, but we change the IP address of that printer, or we change the IP address of a file server, or an Exchange server, any of those kinds of things. And now your users are complaining, hey, how come I can never access this thing anymore? Well, they probably have something in their DNS cache that's still stale. So we can, first of all, look at what's been resolved by doing an IP config and then display DNS. And that's the same as kind of showing the cache on the DNS server that I showed you earlier. Well, this is what's showing me the answers that it's found in its memory cache on a local client here. So there's the server it resolved, there's YouTube. So then there's probably some website for some, what do you call these, ads. You can see there's an ad here in the background. Wow. Anyway, so we can see there's a lot of things going on here. And what if one of these got stale and I wanted to clear them all out again and to perform a fresh DNS query? Well, first of all, I'd have to make sure that my DNS server was also cleared so that it doesn't just deliver stale information back to me to repopulate this cache with wrong information. Okay, so if considering that I've done that, I would then do an IP config /flush flush DNS. Okay, and that will flush the DNS resolver cache. And now if I display DNS again, we don't have anything. So I would have to fully resolve that through my DNS server to get to any of that stuff that I had accessed previously. Let's take a look here at some common types of resource records. That's what R is, resource records. One of those would be A records. That's for IP version 4. These are the most common kinds of records that we'll see, also known as a host record. Then there's a quad A record, which we use for IP version 6. Same thing, just another host record, only it correlates to IP6. There's also pointer records, which are what we have in reverse lookup zones. Not really sure if I can remember showing you that to you when we actually did it. So let's go to our reverse lookup zones here, and we can see this. These are pointer records that point backwards to these servers. Okay, so for example, if I go over back again to my client, and I wanted to do a reverse lookup on 10.10.10.70, I just can't seem to get away from this page. Let's do a ping minus a 10.10.10.70. Then we could say, oh yeah, that's a reverse lookup that's coming back to me as an answer here of dcnugget01.nuggetlab.com. Again, very handy if I want to identify the specific name of a server and I only know its IP address. And I'll show you some of these others by demonstration here in a moment, but that one I just wanted to do right away there. There's also CNAME records, which are very useful for making sure that we can access a specific server without giving up the specific name of that server, at least on the surface. That way, I might have a web farm with 40 different web servers in it for a website, okay, if it's a really busy site. But I don't want people to have to memorize it. They have to go to webserver17.nuggetlab.com. I want them to just be able to go to www.nuggetlab.com and then have other things in DNS take care of the rest. Well, that's part of what a CNAME can do for us. And then MX is a mail exchange record, and that will point to mail servers. All right, so we've actually seen a couple of these already. Pointer I just showed you. Let's take a look, though, specifically at CNAME records to see how that works. What we really want to do here is to have people type www. And then nuggetlab.com in their browser and be able to get to my website, right? However, my website might actually be multiple web servers. So the way I can work with this is to create an alias, and I'll just type in www. Okay, this will allow people to type www.nuggetlab.com in their browser. And let's say that it takes them to webserverfarm.nuggetlab.com. Okay, and click OK. And the problem is that doesn't actually exist anywhere. So what I need to do is to create the host records for that. Let's say my web server farm is actually 3 different web servers, physical web servers or virtual machines, doesn't matter. But let's just say that web server farm is at 10.10.10.200. Okay, and we'll add that host. And then I've also got web server farm at 10.10.10.201. Guess I already did 200. Okay, and then we'll do one more, web server farm at 10.10.10.202, and it created that one. And then now what will happen is it's kind of a rudimentary load balancing. There's actually a lot of other technologies, especially in big server farms, that will distribute this balance much more intelligently. However, what we would have here is someone types in www.nuggetlab.com in their browser, and DNS will take them to webserverfarm.nuggetlab.com. These 3 host entries right here will then perform in a round-robin fashion. It'll go to this one first, then the next client that wants web server farm will go to this one, the next client that wants one will go to this one, and then the next one will go back to the beginning. Okay, so that's kind of how that works, and it's just a rudimentary load balancing method. But that's how CNAMEs work, and it allows people to enter in a commonly known kind of a host record to access something where they don't actually know the literal name of the back end of it. Let's also create a mail record. This would be important if I had my own internal mail system, such as Microsoft Exchange, and I want to make it simple to configure things such as Outlook accounts. So I would just enter in a host or child name and domain, and this would be something like, let's just make it easy. And that's what you want to use this for, is to make it easy. Let's just call it mail.nuggetlab.com. Okay, so there's mail.nuggetlab.com. Now, in reality, the name of my mail server is, west hyphen Phoenix hyphen 05 hyphen building 6. I've typed enough here now. Let's just finish this up. .nuggetlab.com. Okay. Now, It's a lot easier to just type mail.nuggelab.com than to type all of this stuff. Okay, so what we want to be able to do is whenever we configure somebody's Microsoft Outlook, we just type mail.nuggelab.com and don't worry about the rest. And then we can set up a server priority as well. The lower the number, the higher the priority. So if this server is very, very capable, but West Phoenix 07 is twice as capable, then we would give 7 a value of 5 maybe, and we'd give this one a value of 10, and that would be some kind of a rudimentary load balancing, although there's much better and different methods for doing that if you get into Exchange. Anyway, so that's kind of how we can work out with our mail systems as well and MX records. In this nugget, we took a look at DNS. We looked, first of all, at the various types of zones. These were things such as primary and secondary, also Active Directory integrated. We also took a look at a diagram where we just kind of showed how name resolution works, especially if you have to bounce around the internet and go to the root servers and things like this. We looked at forwarders, such as conditional forwarders, and also we looked at stub zones. We looked at the cache on both the DNS server itself as well as on the client side, and we looked at how to clear that cache if necessary. And finally, we concluded with looking at common resource records. Well, I hope this has been informative for you, and I'd like to thank you for viewing.